Hi and welcome to the videos for section 8.3. There will be 4 videos in this section. This is the first video of the 4. In 8.3 we're going to be looking at the polar form of complex numbers and Dwomov's theorem. In this first video specifically, the first thing we're going to look at, so this is section 8.3, and the first thing we'll be looking at is graphing complex numbers. So first, let's recall what is a complex number. Well, that's a number that has the form of the following. It's got the real part and the imaginary part. So a complex number can be formatted as A plus B times I. That I is our imaginary unit to let us know that there's a real part and an imaginary. The A is our real value, and then the sign plus the value of B is our imaginary part, not the I. That doesn't get attached to it. It's just the sign plus that value. If we're graphing these, the graph we use now, it looks similar to our XY graph, but now the horizontal is going to be our real axis, and the vertical is our imaginary axis. So if I have this point A plus BI, that means that I come A units along the real axis, could be plus or minus, and then B units up the imaginary axis. So the point would be here, and it would have coordinates A plus BI. So it's still similar to our graphing the X and Y, it's just now we have our real axis and our imaginary axis. A new term for you guys, or could be a new term, is what's known as the modulus of a complex number. So the modulus of the complex number has the following definition and formula. So you'll at least want this formula on your cheat sheet. You're going to have to use this on some of your exams. So we have the following. The modulus, which you can think of as the absolute value. That'll help you remember the formula come final exam time. But the modulus of a complex number Z, so we're going to give this complex number an actual name, so we'll call it Z is equal to A plus BI. So when we're given this complex number, we want to know its modulus. It's the following. So the modulus of Z, that's what this, so we no longer say the absolute value of Z. If we're talking about complex numbers, we say the modulus of Z. And this is the square root of A squared plus B squared. So what does this look like? This looks like Pythagorean theorem, right? If I have this imaginary graph with the real axis, the imaginary axis, my value of A is this way, B is vertically, so the modulus of the modulus of Z is that green line there, which is essentially the completion of this triangle, because this is A units along the real axis, B units along the imaginary. So the modulus represents that distance from the origin out to the point drawn in the real and imaginary graph. So let's look at a couple examples. Let's say we want to find the modulus We have 2 examples. The first one is Z is equal to 3 plus 4i. So we're going to use this formula The 3 is our A, the plus 4 is our B. So the modulus then is the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16, square root of 25, which is equal to 5. That's it. Straightforward as it is. If you want the modulus, you're basically finding the hypotenuse of that triangle created in the complex plane. So try this one. Z is equal to 8 minus 5i. So go ahead and give that one a shot. Go ahead and set your video to pause. Once you have an answer, come on back, hit play, we'll work it through. Okay, so using the formula, the modulus of z is the square root of 8 squared plus, and here our b is negative 5. So that gives us the square root of 64 plus 25, which is the square root of 89. Can't be reduced, so that's it. We just stop at the square root of 89. Quick and painless, video 1, that's it. So just the introduction of how to graph a complex number. Real axis is horizontal, imaginary is vertical, and then the idea of the modulus, which is essentially that hypotenuse of the triangle we create in the complex plane. So come on back, we'll look at some more stuff from section 8.3 in video 2.